Hey guys, welcome back to the next video. In this video, we are going to talk about one of the important topics of your timeline, which is heap and the heap allocation. Heap allocation is so important for every one of us to understand the importance of the heap analyzing. So this video is going to talk more about it in terms of allocation, cache, and in terms of the different types of heap which you have as part of this IBM JDK 8. All right, let's get going with this. Now, do remember that one of the important concept of heap is just assigning the minimum and maximum memory on your JVM. Now, how is this going to be used? If your JVM is going to be allocated with a specific amount of memory, it is not just going to be assigned for minimum maximum memory. There are so many internal classifications and default values which we are not aware of as an administrator should be. So I'm going to explain you all different concepts in this diagram over here. So I have so many diagrams to make you understand. So let's go ahead one by one and try to explain or understand about this. And do remember this diagram, what you're seeing right now, will be discarded. So if you want to have this, you can take a screenshot from the training video. But I'm not going to have any use with this. This is like a randomly created diagram. So this will be discarded. So over here is a heap. You have the XMS and XMX. So these are the two values which we normally set on our application, saying that this is the minimum memory and this is the maximum memory. So these are the two items which we normally set. So if you do a ps-ef grep of Java, you will be able to see the XMS and XMX over here. I've not changed this item. It is by default chosen by the JVM to have the minimum memory as 50 MB and a maximum memory as 907 MB of a memory. But there are other classifications as well, like these classifications. We'll not understand everything because it's not needed for us to understand every single bit of the memory space, but there is important ones out there which you definitely need to understand. So let's talk about it one by one. Firstly, in terms of heap allocation, you need to understand that the process of managing memory in a VM is handled by an allocator and the garbage collector. We will see the garbage collector later. The next one is about these components which operates on an area of memory that is reserved for VM processing called Java heap. Now, this is a term, Java heap, which is basically used as the reserved component of virtual memory. The allocator assigns area of heap for Java objects, and objects are considered as live when they are having a chain of references to them that starts from the root references. So that's how object is allocated. So objects are basically classes. Okay. Now classes will be starting from the root. We will understand about the class loading and the classes later point of time. I will have a separate video on that to make you understand on it. The next towards is the how we gonna understand or refer or have a pointer, towards this, and how do you understand whether an object is considered as a live object and a garbage object? Because when a pointer or a reference is missing from the root, then obviously the object is considered as garbage. Okay, because it doesn't have the reference, as the pointer no longer exists. So this object is considered as garbage, and the garbage collection will mark it and sweep it. Okay. The garbage collector reclaims the memory by removing this object when they are no longer required or no longer referred by any references for that matter. So depending on the application's workload, the service level agreement, you choose the number of the garbage collector policies. You have to understand your application, the workload, and basically you choose the right policy for your garbage, because there are these two different types of objects out there. There is this short-lived object and long-lived object. Okay, so short-lived objects are applications where people access it People look at it and then they just go to the next one. And then the long-lived objects are something where they will be staying there, okay, and they'll be watching um, the watching the whole thing about. Say, for example, you can consider this as an example also. Like, for example, if you're working, if you're logging into a net banking, so you will be connecting with a database on the back end, you will retrieve the value, and you will not be on net banking forever, right? You will only be there for 5 minutes or 10 minutes to see the amount which you have on your account, and then you log off. So it's a maximum of 2 to 5 minutes is what you will be there. So this is basically a short-lived object where you're not there continuously requesting for something. But a long-lived object, as an example, I can say when you're shopping online, when you're looking at Amazon or when you're looking at any of the shopping websites, and you actually be there, read the reviews, understand the product, and when there is a sale, you're looking for a discount, you keep pressing refresh, or you're watching a live score of a match, you're gonna be there until the match gets over. The match could be a football, it could be a cricket, so it depends on the timeline. So these are long-lived objects. Now, how are you gonna handle these long-lived and short-lived objects based on your garbage collection strategy, which we will talk later. So the allocator on this hand, the allocator manages the pool of free memories and how the free memory is consumed. This is responsible for allocating areas of storage in Java heap for objects at the request of application, class libraries, or virtual machines. In general, allocation requires heap locks on the synchronize concurrent threads that that has access of the area of memory. So if the allocator wants to allocate a specific object, it needs to have access to it. When an object is allocated, the heap lock is released. This is like this is what can I say is like as a real-time scenario is that if there is a insufficient space to allocate the object, allocation fails, heap lock is released. So the garbage collector is called to clean up those messes which is laying around, which is not being used. If the garbage collector managed to recover some space of the heap, the allocator can resume operation. If the garbage collector does not clear or recover any kind of a space over here, it returns as out of memory exception. Now, allocator is everything about heap locks, garbage collection, and out of memory exception. So these three are related to the allocator. In terms of allocator cache, it improves the performance of the allocation because you are going to create a reserve or a cache in different parts of your heap. These allocation caches known as thread local heap. This is THL, which means thread local heap. These allows the threads to allocate memory in cache without acquiring the heap locks. So it doesn't have to have the heap locks, which was the allocator using it earlier to allocate the objects in the memory. Okay, so as this cache will be between 2 KB to 128 KB, you can also increase the size of this cache to have more caches available for your allocation to happen. But it is always recommended to keep it at the default level unless until it is advised to do otherwise. So the next one we're going to talk about is basically the concepts of action item over here. That's one thing. Just a second. Yeah, these ones over here. So now your area of heap is divided into multiple items over here. So as of now, what you have given over here is your XMS and XMX, right? So you are defining this in a simple way. Just give me a second. Sorry about that. I got a call. So area of heap is basically what we set on XMS and XMS, but then within that, there is a lot of segregation over here. Let's try to understand the segregation in terms of these two aspects. We don't have a permanent generation or a metaspace like we used to for the sun hotspot, but we have these two classifications over here. So the first classification is called as young generation very popularly. Now in IBM we call it nursery area. So this is where the first created objects would pop up in. So this is what we call it as a Eden space or allocate space over here. So in IBM JDK, we call it allocate space. In Sun JDK, hotspot, we will call it as Eden space. Now this is where all your new objects are going to pop in. And then you're going to have this division over here for survivor space and survivor space 1. Okay, that is supposed to be an arrow over here. Just give me a second. Well, there you go. Now you have it. So you have the survivor space and the survivor space 1 over here. So this is basically how the heap is divided. And also you're going to have this XMN, XMNS and XMNX. Okay, so this is basically for your young generation or nursery space allocation over here, where you have the option of giving your minimum a young generation space and the maximum young generation space, a nursery space. So this is basically to sort out from this. So it will take from whatever is given over here and it will just sort it out from here. Okay. So that is a basic thing over here in terms of nursery space. What is the use of survivor 0 and survivor 1? We will talk in some time. Okay. This is just an introduction. So we're not going in depth about all these things, which we will do it on the next video. So here we have the old generation or the tenure area. So whatever survives from here will be gone over to your SOA and LOA. So what is SOA? SOA means that it is a small object area and LOA is a large object area. Now this basically means that all your large objects are going to come in over here and SOA, small objects, are going to come in over here. Now, do remember that when you have a large object coming in over from the directly, a new object is getting created and it's so large that it cannot fit your Eden space, that object will directly come over on LOA because you don't have space on the Eden space to get to the survivor space and then for it to survive and then come over here. That's not going to happen for a larger object. So in that situation, the LOA will directly assign the new object, which is larger. And when it understands that it cannot be fitted directly into your Eden space or your young generation after all, then it basically gets aligned to your LOA space. So to understand more in detail about the area-based heaps, the default garbage collection policies on your IBM JDK 8 uses heap configuration that is divided into two main areas: the nursery area, where the new object allocation, and the tenured area for the object to continue for the reachability of a longer period of time. So most objects have a short-lived life cycle that can be reclaimed by the garbage collector, which is more quickly by focusing on the nursery area. That is a whole reason why we have this nursery area over here. The garbage collection cycle that causes application pause in order to clear and defragment the tenured area, which are less frequent. So this is one more concept which we will understand at a point of time in garbage collection is the pause, the stop of the world pause, which we will talk more on the garbage collection time. So we will not be discussing much on that. In terms of SOA and LOA, all areas based heap subdivided into the heap and split into SOA and LOA. The allocator initially attempts to allocate objects in the SOA regardless of the size. If the allocation cannot be satisfied, in the following actions will be taken. Like for example, if the object is smaller than 64 KB, an allocation failure occurs that triggers GC action. If an object is larger than 64 KB, the allocation attempts to allocate it on the LOA directly rather than assigning it to SOA and then using the garbage collection, because it won't fit into SOA's small object areas criteria. So if the allocation cannot be satisfied, an allocation failure happens, which triggers a garbage collection again. The GC action or the garbage collection action that is triggered by the allocation failure depends on the GC policy in force, and whatever the GenCon, which is the default garbage collection, would kick in, and it will start to reduce the allocation over here. Now, you can use the options over here of LOA over here, where you can specify the LOA initial size, the LOA minimum size and the maximum size, where in which the same thing as your young generation or nursery area, where you have the initial, minimum, maximum in terms of young generation. The same thing can be done for LOA, but this is only for LOA, so it will be automatically taken in whatever left over. And there's option also to disable LOA after all, because if your application is using only SOA and you're pretty sure that it's not going to use LOA, you can also turn it off as well. So that is option which is also given over here. Now you can control the size of the LOA by using these parameters. All right, so pretty much we have covered the minimum understanding of what we wanted to talk about in terms of HEAP. I hope that you have a little extra knowledge right now on HEAP and in terms of IBM JDK towards that. So next few videos, we will gonna compare and understand the garbage collection, when it kicks in, where it kicks in, why it kicks in. Okay, so we'll understand that, and we will talk more about this later on. If you have any questions, please leave it on the question section. I'll be happy to assist you in that terms. I'll see you on the next video. Until then, bye-bye.